We're going to be continuing our talk on gene expression. Gene expression is also called protein synthesis. Specifically, we're going to talk about the second of the universal stages of gene expression, this being translation. Just a very quick recap of the universal stages: transcription and translation. In transcription, an RNA copy of our DNA gene is made, and it is now brought to the ribosome, one of many ribosomes, where we will continue our talk. The ribosome can read the mRNA, so to speak. Every free RNA nucleotides, every cluster of free RNA nucleotides is referred to as a codon. And it will use these codons to determine what amino acid to use in making the protein. Now, as you may know, proteins are really just polymers of amino acids. In the human body, there's up to 20 different amino acids that can be used. For example, the amino acid methionine corresponds to the RNA codon sequence AUG. But even before we can do any of that, translation can only occur when the ribosome attaches to the 5' end of the mRNA and recognizes the start codon, which coincidentally is the same codon for methionine, AUG. What will happen is a molecule called tRNA, transfer RNA, will bring the corresponding amino acid to the ribosome, where the ribosome will add it to the polypeptide chain. As you know, a protein is, of course, it's really just a chain of these amino acids. This chain will react with itself and will eventually form our protein. There's specific regions on the ribosome. I always remember the names of the site because it spells out the word ape. We have the P site, which is where the first codon will be read. We then have the A site, where a second codon will be read. And then after those are read, the ribosome will move towards the 3' end of the mRNA. However, the tRNAs are still attached to the mRNAs. Of course, the tRNA is attached to the codon of the mRNA by their anticodon. tRNAs have an exposed codon of their own called the anticodon, which is completely complementary to the codon that they correspond with. At the E site, now the tRNA that was in the P site will be moved to the E site, and the tRNA that was previously in the A site will now be moved to the P site, and now a new codon can enter the A site, and now a tRNA can occupy that codon and give us the next amino acid. At the E site, the tRNA will be ejected into the cytoplasm, where it will pick up a new amino acid. This process will continue until we reach the stop codon. Now, I'm going to be honest with you guys, I can't remember the stop codon sequences, but there's 3 of them, and I'll put them on screen now. Once the stop codon is read, a protein will come and will separate the mRNA from the ribosome, thus ending the process of translation. If this were a prokaryote, this would be the end of the line. You would have a fully formed protein. However, we should discuss all that we can about gene expression in this series. We're going to, next episode, talk about eukaryotes more. Specifically, eukaryotes have a modification stage for translation, as they do for transcription. Join me next time, and I hope you've enjoyed. Thank you.